What is row scanning here? Identify the least element in that row and subtract each and every element by that row. That after completing row and column minimization, we have to go for row scanning and column scanning. Identify the least uncovered value as X. Hello dear students, welcome to this session of Operation Research over class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Now in my previous class, we have discussed a problem on assignment using Hungarian method. So finding a solution of a transportation problem using Hungarian method. Now here also I am going to take one more problem regarding this assignment problem. Let me discuss an assignment problem. So solve the following assignment problem using Hungarian method. The matrix represents the processing time in hours. So this is the processing time in hour. We have to assign for a particular operator using an Hungarian method. Now first, let us verify whether this is a balanced assignment problem or not. How to verify? Just check whether it is a square matrix or not. Just how many rows are there? So this contains 1, 2, 3, 4 and 5 rows. Number of rows into number of columns. So the number of rows are 5 and the number of columns 1, 2, 3, 4 and 5. So number of rows is equal to number of columns. So therefore this is a balanced assignment problem. So this is a balanced assignment problem. Now what is the next step? Just go for row scanning and column scanning. What is row scanning here? Identify the least element in that row and subtract each and every element by that row, that least element. So here what is the least element? 7. Subtract all the elements by 7. Next, what is the least element? 6. Subtract all the elements by 6. Next, what is the least element? 6. Subtract all the elements by 6. What is the least element here? There are two least elements. You can select any one. 9 is the least element. Subtract each and every element by 9. Then what is the least element? 7. Subtract each and every element by 7. Okay, that is called the row scanning. Let me go for the row scanning. So 9 minus 7 is 2. 11 minus 7 is equal to 4. 14 minus 7 is 7, 11 minus 7 is 4, 7 minus 7 is 0. Similarly, 6 minus 6 0, 15 minus 6, 15 minus 6 is equal to 9, 13 minus 6, again here 13 minus 6 is equal to 7, again 13 minus 6 is 7, 10 minus 6 is equal to 4. Again 6 is the least value, 12 minus 6 is 6, 13 minus 6 is 7, 6 minus 6 0, 8 minus 6 is 2, 8 minus 6 is 2. 11 minus 9, 9 is the least value, 11 minus 9. So 11 minus 9 is equal to 2, 9 minus 9 0, 10 minus 9 is 1, 12 minus 9 is 3 and 9 minus 9 is 0. Again 7 minus 7 0, again 12 minus 7 is equal to 5, 14 minus 7 is 4, 10 minus 7 is 3, 14 minus 7 is 4. That is what we are going to write. So let me write 9 minus 7 is 2, 4, 2, 4, 7, 4, 0. So these are the values we are getting by row minimization. Similarly, come to the, after doing row minimization, from this row minimization, go for the column minimization. Identify the least element in this particular column. Here it is 0, here it is also 0, here it is 0, here the least element is 2. Here it is 0. So, if the least element is 0, there is no change. So, there will not be any change, because if you subtract anything, any value, if you subtract 0 from any value, you will get the same number. So, this will remain the same. So, that is 2 minus 0 is 2, 0 minus 0 0, 6 minus 0 is 6, 2 minus 0 is 0, 0 minus 0 is 0. So, you will get 2 0 6 2 0. In the second row, 4 minus 0 is 4. 9 minus 0 is 9, 7 minus 0 is 7, 0 minus 0 is 0, 5 minus 0 is also 0. In the third column, 7 minus 0 is 7, 7 minus 0 is 0, 0 minus 0 is 0, 1 minus 0 and 7 minus 0 will be the same. Now, whereas in the fourth column, there is a change. We may expect we will have a change. 4 minus 2 is 2, 7 minus 2 is 5, 2 minus 2 is 0, 3 minus 2 is 1, 3 minus 2 is equal to 1, and in the last column, this is 0. If you subtract anything from any value, you will get the same value. So, if you subtract 0 for any value, 0 minus 0, 4 minus 0, 2 minus 0, 0 minus 0, and 7 minus 0. So, this is how we are going to perform row minimization and column minimization. After completing row and column minimization, we have to go for row scanning and column scanning. Now, let me come to the row scanning. Now, in row scanning, let me write all these elements as usual. As usual, I will write all the elements here. So, this is 2, 4, 7, 2, 0, 7, 2, 0, again 0, 9, 7, 0, 9, 7, 5, 4, then 6, 7, 0, 0, 6, 7, 0, 0, 2. Next 2, 0, 2, 0, 1, 1, 2, 0, 1, 1, 0, and next is 0, 5, 7, 0, 5, 7, 1, 7. So, this is the values from the previous line. Now, just go for the row scanning. Identify the zeros. So, here, see here 1, 0 we have. So, mark this 0. Once if there is, we are doing row scanning. So, we can, while doing the row scanning, we can cancel all the elements in that particular column. Okay. Next, come to the second row. Here it is 1, 0. Once there is a 0 mean, we can cancel that particular column. Next, in the third row, this is first row, second row. In the third row, third row, there are 2 zeros. We can go for the next. Here it is 1, 0 and cancel this particular column. So, these are called the row scanning. Now, come to the column scanning. While coming over to the column scanning, so the same thing I will write here. This is 2, 4, 7, 2, 0, 0, 9, 7, 5, 4, 6, 7, 0, 0, 2, 2, 0, 1, 1, 0, 0, 5, 7, 1, 7. Where we have marked the circles, this is 1 cancelled, and here it is, this 0 is also cancelled, and then this 0 is cancelled. That means we have cancelled this row, this column, and this. Now come to the column scanning. Whereas in column scanning, identify the 0 in the first column. This is cancelled, this is also cancelled. Here 0 is here. In the third column, 1, 0, identify this 0. So, once if this is we can cancel this particular row. This is cancelled. Again, go to the next, no zeros, no zero. See the number of lines, 1, 2, 3 and 4. The number of lines drawn are 4, but the order is equal to 5. So, number of lines drawn is equal to 4, but the order of the matrix is equal to 5. So, 5 is not equal to 4. So, here the number of lines drawn are 4 and the order is equal to 5. Number of lines drawn is not equal to the order. So, therefore, the optimality is not reached, not feasible. Again, we have to go for the next step. Okay. So, here the solution is not optimal. So, not optimal, then we have to go for the next step. What is the next step? Identify the least uncovered value as x. So, let us identify the least uncovered value. The uncovered value is the 7, 2, 9, 7, 5, 1, 1, 7. So, in this least value is this. Let us consider this as the least value. Okay, 1 is the least value. Now, just subtract each and every element by 1 for the uncovered and add 1 at the intersection of the lines. So, you can subtract 1, 1, 1, 1, 1, 1, 1, 1, 1 here. And what are the elements we are going to get? Let me write here. This is 2, 4, 2, 4, 7 minus 1 is 6. Again, 2 minus 1 is 1, 0 as it is, okay. Then 0 as it is, 9 as it is, 0, 9 as it is. Again, see here, 7 minus 1, 5 minus 1. 7 minus 1 is 6, 5 minus 1 is 4. 6 and 4. Then the last element is 4 as it is. Again, see here, there is an intersection. Here is also an intersection. So we can add 1. 6 plus 1, 7 plus 1. 6 plus 1 is 7, 7 plus 1 is 8. 7 and 8. And the remaining value is 0, 0, 2 as it is. 0, 0, 2 as it is. Okay. Here 2, 0, 1 minus 1, 0, 1 minus 1, 0, 0. 2, 0, 2, 0, 1 minus 1, 0, 1 minus 1 is 0. Again that 0 as it is. And the last row 0, 5, 7 minus 1 is 6, 1 minus 1 is 0 and 7. 0, 5, 0. 0, 5, 7 minus 1 is 6, 1 minus 1 is 0 and the last element 7 as it is. Now, here in the first row we have 0 here, 1, 0 and for the second row we have 0 for first element, this is marked box, and then where we have taken for third element as 3, this is we have marked. And for fourth line, this is 0 here. Now, just identify here, this row is cancelled, number of zeros are cancelled, here also cancelled, here it gets cancelled. So, here it is cancelled. Okay. Now, after finding the values, now let us go for row scanning and the column scanning. So, already we have scanned. What are the lines we have scanned? First, second and last. First, second and the last. Whereas column, so we have scanned this third. Okay. Now come to this. Now let us go to the row scanning first. First row, in first row is 0 is cancelled. In the second row this 0 is cancelled. In the third row we are cancelled. In the fourth row, so in fourth row we have 2 zeros, we can leave. And whereas in the fifth row only 1 0 you can. So, you can cancel this, right. See here now, the number of lines drawn 1, 2, 3, 4, 5. The number of lines drawn is equal to 5 and the order is equal to 5. So, 5 is equal to 5. Therefore, the optimality is reached. The optimality is reached. Now let us come to this. What are the jobs and the machines? Now we can write. For job 1, the machine number is 5. 1 to 5. Next, 2 to 1. 2 to 1. For third it is 3. And for the fourth one it is 2. And for the fifth machine it is 4. Now you can substitute the values. 1 to 5 for first. Now write on the cost. 1 to 5 it is 7. Again 1 to 5 it is 7. We can write 7. 1 to 5. 2 to 1. 2 to 1 it is 6. Again 3 to 3. 3 to 3 it is 6. Again 4 to 2 and 5 to 4. 4 to 2. 4 to 2, 9. Okay, now just substitute the values. So what are the values we have? 7, 6, 6, then 9 and 10. That's it. Okay. Now substitute here. What are the values? 1 to 5, that is, it is 7. The cost is 7. 2 to 1, 2 to 1 it is 6. 3 to 3 is also it is 6. 4 to 2 it is 9. And 5 to 4 it is 10. Add. What is the total? 10 plus 9, 19. 19 plus 6 is 25. 25 plus 6 is 31. 31 plus 5 is 38. Okay, 38. So therefore, the total time taken is 38 hours. This is the time. So therefore, the total time taken 38 hours. That's all. So the total time taken is equal to 38 hours. That's all. Okay, hope you followed this. That's all regarding this session. Let us meet with a different concept in the next class. Thank you very much.